Hello guys, in today's class we will discuss k nearest neighbor. Okay, so k nearest neighbor is a simple and intuitive supervised learning. So you know it is a supervised learning algorithm used for classification and also for regression tasks. Okay, it is also a classification and also a regression task. It works based on the principle that similar data points tend to belong to the same class or have similar output value. Okay, that have same class or have similar output value. Okay, suppose it is used for classification and also used for regression. Suppose let some features we'll discuss some example. Suppose you notice here, okay, there is some features. So okay, there is some features. Okay, and some data points are like this, 3, 4, 1, 2, like this, and some are like this, like this. A new data point will occur like this. So it is a new data point. Not market data. It is a new data point. Okay, and here you assume let k equal to 5 and there is features that is f1 and f2. Your output will maybe yes or maybe no. Okay, and it is your suppose f1, it is your f. Okay, so a new feature will come and you notice let k equal to 5. So k nearest neighbor. Suppose you notice it is one nearest neighbor and it is also 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 one neighbor. Here you notice in 5 k means k nearest neighbor, that is KNN. In 5NN, that is in 5 nearest neighbor of this data point, there are 3 are present in, suppose it is your S and it is your no. Okay, in S and 2 are no. So majority is 3. So answer is S. In S, that is the k nearest classifier is present in S. Okay, so but the process is first work is we have to initialize the k. It is your first one, that is k equal to 1, 2, 3 like this, that is a hyperparameter. Okay, and second work is find the k nearest from the new test data. Okay, after that maximum number of points is in red cutter, sorry, is in green cutter, green cutter. So test data will be green category point. It is the processor of k nearest. First we initialize the k value. Suppose here we initialize the k equal to 5. Then find the k nearest from the new test data. We will find the k nearest neighbor. Then maximum number of point is in green category. Here you notice maximum point in green category. So testing data will be green category point. Okay, it is the procedure. Here you notice. So first example is one nearest neighbor. Here you notice that is one nearest neighbor. Suppose it is your new data point and it is present in minus. So output will be minus 0. Here you notice in two nearest neighbor, that is first you move minus then plus, then it is maybe minus, maybe plus. Okay, and three nearest neighbor. So here you notice in three nearest neighbor there is 1 plus, 1 minus and 1 plus. So plus, that is output will be plus. Suppose for k nearest neighbor we will assume k as odd number. Okay. Because it is better for we assume k equal to odd number. If you assume k equal to even number, may be possible of this problem like this. 1 is minus, 1 is minus. So k nearest neighbor of a record x, okay, are the data point that have the k smallest distance to, okay, that is x is the new data point. So accordingly we define the 1 nearest neighbor, 2 nearest neighbor and 3 nearest neighbor. Okay. So next we'll talk about the example. Suppose there are 5 examples, some pepper, ginger, chili, like, okay, are given. Suppose it is given as true, 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 and like this, false. Okay, and true, false, false, true, and false, true, true, false, and false, true. Suppose false, it is also true. If you assume this is true, false, false, true, like this. Okay. Now you will calculate the distance. How? Suppose one is given before is your false and ginger is your true and chilli is your true. Then it is false or true. It is liked or not liked. You will calculate. Suppose you would assume paper. Here you notice that is false and it is true. That is changes. So distance will be 1. If it not changes, then it will 0. Suppose here assume true, true. It is 0 and it is also 0. So distance will be 1. Similarly, here you notice false true. So here is 1, here true false, here is also 1, and here true false, that is here is also 1, that is 3. Now here you assume false true true same, so 0 plus 0 plus 0, that is 0. Okay. Similarly, here you would notice first one is 0, then true to true, that is 0, and true to false, that is 1. So 1. And last one is false to true, that is also 1, true to false 1, false to true, that is also 1, that is 3. Suppose here you notice that is the first minimized distance, that is the first minimized distance. So here in 3NN, here we will take the 3NN classifier. So here we assume it is our first classifier. Then we assume that is 1, that is second classifier, and that is third classifier. So here first nearest neighbor is C. Okay. So it is an example of k nearest neighbor. So then key parameter of KN. Okay, so the first one is the K. So here K is the number of nearest neighbor consideration for classification or regression. It is an hyperparameter that needs tuning. We'll discuss then distance matrix. To measure you to compute distance between data points such as we'll calculate Euclidean distance and mean error. Here you see what is Euclidean distance. Okay, Euclidean distance. In Euclidean distance, suppose it is 2 point and if you draw the line like this, okay, and it is your x1, x2, and it is your x1, y1, suppose, and it is your x2, y. So Euclidean distance will be root over x2 minus x1 whole square plus y2 minus y1 whole square. It is your Euclidean distance. Okay. And second distance is Manhattan distance. Second distance. Okay. In Manhattan distance, you notice, suppose it is your is your ABC. Okay, here you notice, suppose it is x1 and y1. Okay, sorry, that is x1, y1, and it is also your x2, y. Here now you calculate the distance of AC. So how will calculate? So AB plus BC. AB plus BC. So we calculate like this distance x2 minus x1 penalty plus y2 minus y1. Here you calculate the x2 minus x1 cardinality, this distance plus y2 minus y1, this distance. So like this we will calculate the SC equal to FB plus BC. Okay. So after that, advantage of K. So advantage is first advantage simplicity. It is very simple. So KNN is easy to understand and implement, making it is suitable for beginner and quick prototyping. And it is also non-parametric. That is, it does not make assumption about the underlying data distribution, making it versatile and robust also. And last one is adaptability. That is, KNN can handle both classification and regression tasks as well as multi-class classification problem. It is used for classification and also for regression and also for multi-class classification. So you have doubt how the KNN work. You have doubt how KNN work. Okay. We'll discuss first work is our data representation. Data represents. So each data point is represented as a feature vector in multi-dimensional space. Okay. And second one is your classification. So for a new point, a new data point, KNN finds the k nearest neighbor based on a distance matrix. That is maybe your Euclidean distance or maybe your Manhattan distance. So third one is majority voting. Okay. In classification, the class level of a new point is determined by the majority voting among its k nearest neighbor. Okay. And last one is your regression. In regression, the output value for the new point is computed as the average of output value of its k nearest neighbor. Okay. So you have done some application or real life application. Okay, so first application is that medical diagnosis. So in predicting the disease based on patient features like symptoms, test results, or medical laboratory. Okay, and second one is most popular, that is recommendation system. So collaborative filtering in recommendation engines based on user items similar. It is your second application. And last application, suppose one last application example is anomaly detection. So identify outlier or anomalies. Anomaly which? That is the outlier. Identify the outlier in the database on their proximity to other data point. It is an anomaly detection. So these are the real life application of KNN. Okay. So thank you.